Hey guys, welcome back to our seventh, I think, Arduino tutorial. And this one is going to be on buttons. Okay, now you may say to yourself, a button, isn't that just a digital read and then you just do whatever you want based on, whether it's high or low? Yes and no. Um, the button is more than just that. We could use the button for multiple selections. Actually, we're going to do that now. We're going to do that today. So a couple of things we're going to do with the button is we're going to press it and have a light come on, and when we let go, the light will go off. Another thing we're going to do with the button is we're going to press it, the light will go on, and then when we press it again, the light will go off. And then the third thing we're going to do with the button is we're going to press it once, something's going to happen. We're going to press it a second time, an additional thing's going to happen, and we're going to do a third and a fourth, and I'll show you how you can have an unlimited selection with one single button. So if you can already do all that, then sure, skip this. But if you can't, you may want to tune in for the button tutorial. Okay. First thing we're going to do is we're going to, from our sketchbook. Oh, I also wanted to mention something. The website's almost done, so I'm going to be publishing the code. You'll see a link in the description box below, and I'll do the same for the previous tutorials, and I'll publish all this code so you guys can just download it. It's pretty simple right now, but we're going to have more code as we go along. Okay, let's take our sonic sensor and the code from our sonic sensor. Let's expand this a little. What we're going to do is we're going to edit this code. One of the reasons we're going to edit this code is because I want all these here. We're going to have one single button that'll do each of these when we're done. So you will press the button once, it'll do this, second time, third time, fourth time, fifth time. Okay, so let's see. So 5 different things, I guess, on the buttons. Okay, so let's do a little review and see what we need and see what we need to get rid of. The first thing we're going to do is we're going to save it. And we're going to save it as, under Arduino tutorials, we're going to call it I guess we can call it a people sensor since it's a button. But we're going to call it, we're just going to call it button. Although people sensor is cool. And we're not even going to call it a sensor, even though a button is a sensor. It detects a push. Actually, let's call it button sensor. We can pretty much do whatever we want. So we're going to call it button sensor. And we have an init green LED. We have an init yellow LED. We're keeping all these. Init red LED and init buzzer 12. Okay, so we're keeping all those because these are the things we're going to control with our these are the things we're going to control with our button. So, but we don't have the sonic sensor anymore. So we're going to remove the sonic sensor. And we're going to call it button. Now, you'll notice we have button and it equals 5. We're actually going to use a digital pin. We used an analog pin for our sensor. But remember, it's not this number that determines whether it's an analog or a digital pin that we're using. It's what we do. Down here we have the analog read sonic sensor. Well, that determined that the analog read determined that it was going to use the analog pin 5. So you know what we're going to do? We're going to keep this as 5, and we're going to make it digital. So that way you see the difference between those two. And instead of sensor value, we're going to have button state. The state of the button. Whether it's pushed or whether it's not pushed. And we're going to start off with 0 for our button push. So our initial state is going to be 0. Okay, we have our void set up now, And if you remember, we didn't have pin mode for the sensor and have it as an input, because the analog sensors, we don't need to do that. But the digital sensors, we do. So if we go to our help, and the reference is your best friend, we're going to do modulus in this particular one too. Pin mode, we have input or output. And of course, we want to have our button, our digital pin, our button, we want to have it as an input. So actually, let me get rid of this second Arduino here. Okay, and code for our button. And we decided to call it a sensor. Okay, so we're going to call it the button sensor. And now we need pin mode, button. So pin mode for 5, our button, comma, input. And remember, this is case sensitive. So now our pin mode for our button is an input. We're still going to use the serial port, just so we can see when we get a little more advanced in the button, we can see the state changes. So we'll keep the serial in here. We have our void loop. We have sensor value. Oh, actually, I think we need another variable. Okay, we need one more variable here. Remember, we're flying by the, or I'm flying by the seat of my pants. So we need button, we'll call it value. And that's going to equal 0. Now, we're not actually going to use the button state just yet. So we'll rem that out this way. Another thing we want to do is we'll come down here and see all these if statements here. Right down to here. We're not going to rem this guy out because this is the closing brace for the void function. The void loop function, sorry. Void's not a function. So I'm going to move him down a couple of lines. And what I'm going to do is I'm going to do / asterisk. Now that has remmed out all this stuff down to here, but we don't want this last brace remmed out. So now we're going to do asterisk / and see that I don't know if you could notice on the video, but now that is not remmed out down here. That's not shaded gray. That little brace down there. So pretty much we've remmed out all this code for now because we're not going to use it right now. We're going to change it. We are going to use it. We're just not going to use it right this second. So instead of sensor value equals analog read sonic sensor, what we're going to do is we're going to do button value equals, remember, we're using the digital pin now. Digital read. And what are we going to read? We could put 5 if we wanted to read 5. But we created a variable called button that represents 5 for us. So now we have button value. Remember, case sensitive here. We have button value equals digital read button. So that button value is either going to be high or low because we're reading a digital pin. And digital pins are either high or low for their input. Okay, so we're going to do another if statement. And earlier, if you remember with our other sensors, we did if and then if else and if else and if else. We started with the more complicated. This is going to be a little simpler. So what we're going to do here is we're going to say, we're just going to do an if else is what we're going to do. So we're going to do if button value equals equals, you need two equals. This equals was saying whatever this is, we want it now to this value to equal whatever this is. But here we're doing, it's a comparison operator. We're comparing. Does what we're saying here, does button value equal high? And if you notice, high is in blue because it is a system variable. So I couldn't name something high because it's already in existence. So what was it? This is a conditional. So if button value equals high, then perform the code below. And what are we going to do? We are going to turn on our green light. So that would be digital write and our green it's green LED digital write LED so we're going to turn that green LED on. If button value is high, meaning we're pressing the button, we're going to turn that green LED on. And ending brace, because that's the end of this code. We could put a couple more lines of code if we wanted to in there, but we're not going to. Else, now notice there's not another if here. We don't need another if here. So this is just else. If we look down here, we could actually end this with just else instead of doing else if. But we have else. Else. Digital write. Green LED, comma, low. And then an ending brace there. Now don't forget, we also have a brace down here. And we can get rid of the map statement because we don't need to do any mapping in this. And we don't want to print our sensor value. What we want to print here, and we're not going to use the serial monitor just yet, but when we do use it, we want to print our button value. And let me bring this up here. Okay, so we're not using, actually, let's rem out everything we're not using. And we're using the green LED. We're not using button state. And this way you can just see better what we're doing. And button is an input. Okay, so this is the code we're using. I may have said this before. I'm remming this out. I'm remarking it. It's rem stands for remark. So now it just becomes comments instead of actual code that things are paying attention to. And like I mentioned before, there's two ways to do that. // will do the single line. /* will do everything in between itself and then the asterisk /. So we've run this out, and I know it looks a little busy, but instead of typing this out, you know, my videos are long enough with me rambling without having to retype all this out for you guys. And the code, I'm not going to, actually, I guess I could include the code of each one of these. So let me do File, Save As, Button Sensor 1, Save. So we'll do each one, Button Sensor 1, Button Sensor 2, Button Sensor 3. There's going to be 3 of these, I believe, unless I change my mind midstream, which has been known to happen. Okay, so let me review my code. green LED. Okay, and let me not plug in my Arduino because that's I gotta. You guys shouldn't follow my bad habits. Okay, so now I'm gonna pause this, and we're gonna go and remember this ending brace here. We need that. I actually could put it up here if I wanted to, and then just have the void loop this way, and put that ending brace there, and then all this commented code can be outside of that. Actually, let me do that, just so you guys can see. So we'll put that ending brace here. So now if I look at right here, my void loop, see, there's my beginning brace and my ending brace. So there's my code for that particular function. Same thing in setup right here. And these braces here, this right here to here, and then here to here. It encapsulates my code. Okay, so now let's pause this and build our sensor, our button. Okay, guys, you'll notice for the first time ever, I'm actually doing this right, and I have, actually, let me remove some of this stuff. I am actually building this without power to the Arduino, which is what you should do. Because you don't need to power this up to build this. And I've never had a problem with it, but you know, if you don't have power to it, if you accidentally connect something you shouldn't, and you catch it before you add power to it, it could save you headaches. Anyway, okay, here's our button sensor. Now, I've looked at this prior to this, and it is a little dark here. Let me see if I can shed some light on this. There, I think that's a little better anyway. And keep that light a little off camera. Okay, so here's my button, and if you watch the electronics tutorial, you can use a continuity tester on, see there's 4 pins here? Now when I use a continuity tester, for those of you who actually watch the electronics videos, I just happen to know what this button is. If I do a continuity tester here and here without pushing anything, I'm going to get an alarm, which means these two are connected. And if I do the same thing, and if I push the button, they're still connected. So basically, this is a button. It looks like it's a multi-purpose button, but it's not. But if I connect my continuity tester to this one, and you can go, I'm not going to do another tutorial for the Arduino, you can go back to the electronics one. Connect it to this one, and this one, if I'm not pressing anything, there's no continuity, no buzzer. But then if I press it, I get continuity. So between these 2 pins is what the is the button. Now, it's actually between these 2 pins too, so I could use either of these. But what I'm going to do is I'm going to put this guy between these 2 here. So we have our gully trough, whatever you want to call it, in the middle of this. And actually, let me move it over one more. So we're going to use this side here is what we're going to use. This side here we're just going to ignore. So we'll use this side here. And what we need to do is we need to take 5 volts. Now, actually, I will review this setup again, even though this is the same output. We just built this output for testing the input. Later on, we're going to be doing, manipulating outputs. Like I said, AC devices, motors, PNPs, NPNs. I already went through in the introduction to where these tutorials are going. Some of the different outputs we're doing, Ethernet, wireless, all that kind of stuff. But so we're just keeping this standard setup we're just keeping this setup for the inputs, so we can have some feedback, some visual feedback for the inputs. Once again, Now, I should mention, I don't know if I mentioned it, I think I mentioned it in the first tutorial. I don't know if I mentioned it in the last tutorial. But these LEDs here are powerful LEDs that can take 4 or 5 volts without a resistor. What we have coming out of these digital pins, except for pin 13, it has a resistor. All these digital pins, it's coming out 5 volts without a resistor. For these powerful LEDs, I'm using a 270 ohms resistor. If you have less expensive or less powerful LEDs, I mean, these guys can kick up to 25 milliwatts. If you have less powerful LEDs, or you're not sure what kind of LEDs you have, and you don't have a data sheet on them, I recommend either using 470 ohms resistors or 1K resistors. And to understand any of that, there's a breadboard tutorial under electronics. There's resistor tutorials under the electronics tutorials. So I'm not going to review that too much, other than to say these are 270 ohms resistors, and I mentioned that in the tutorials, but you may want 470s or 1Ks depending on the LEDs you have. You should be okay with 470s. It's only 5 volts, so 470 should be fine for that. Okay, so what we have here for our setup for our output, we have digital pins 9, 10, and 11. We're using green and 9, and then it goes to a 470 ohms resistor, 270 ohms resistor, into the long end of the LED pin. There's a long end and a short end. Long end is positive, short end is negative. And then the short end goes over the ground rail. There's also a flat portion on here. I know people who are watching all my videos are getting sick of hearing me saying that. But you guys can, these videos they're available under Creative Commons licensing, which means you can download them, and you know, if someone else sees them, they may not get this information. So then we have the ground that connects to the ground on the Arduino. So we have the green and 9, the yellow LED in 10, and the red LED in 11. You know, all with 270 ohms resistors. Use 470 ohms if you don't have these special LEDs. And then out of pin 12, we go into the buzzer. This buzzer, I forget what it is. I think it can take up to 24 volts. It's either 12 or 24. We're only pumping 5 volts into this buzzer, so we don't need a resistor for this buzzer. So it's coming out of pin 12, digital pin 12, into the positive, and then the negative is plugged into that negative rail, and they all go into this negative rail, and they're all feed back to the negative here. So they get the positive voltage from the digital pins, and then one negative that goes back to the negative. And we have 2 negative inputs here, and we're going to use another one for the button. Okay, now for the button, if you remember, we're going to we need to power our button, and the sensor is going to be on digital pin 5. But we need to power the button. So the first thing we're going to do is we're going to plug into 5 volts. And we're going to put that 5 volts over. I'm going to put that 5 volts over to one side of our button. Now the other side of our button, it would be great if we could just say, okay, we're going to take the other side of our button, and we can do this. Once again, we're not plugged, the Arduino is not plugged into anything. So we can take the other side of our button, and we're going to plug it into digital pin 5. 0, 1, 2, 3, 4, 5. Starts with 0. So this would actually work for the first time we press the button. Then it would stay high. If you remember, we need a pull-down resistor. A pull-down resistor, so that what happens is when we're not pressing this button, that voltage still is sitting there. We need a way for it to drain away. So what I'm going to do is I'm going to take our favorite pull-down resistor, 10K, and I'm going to put it in the same row. Actually, I'll start telling you what these are. One side of the button is in 9E. The other side of the button is in 7E. I have the positive plugged into the 5-volt positive on the Arduino, into 9D, it's plugged into 9D, and then the sensor itself is plugged into 7A and then over into pin 5. So now I'm going to plug one side of my 10K resistor into, we'll use D7, and the other side into D3. So we're going from D7 to D3 with that 10K resistor. Now what we want to do, let me see if I got another long black cable. I got a bunch of short ones. I guess I can use one. No, let me get a longer one. We'll use a long blue one. We'll use a long blue one. So now we're going to take this long blue one, which we're considering our ground, and we're going to put it in B3. Remember, the other side of the 10K resistor is in D3. We're going to put it in B3. Come here. Okay, B3. Now I could put it in A3 or C3 or E3, whatever is available there. I don't have to put it in there. I'm just letting you know where I'm putting this. And then this comes back over to the second ground on the Arduino. And I will do a close-up of this. Of this particular configuration. Now this is all the configuration we're doing. From now on we're going to be changing the programming to get different results. So I'm not going to do the close-up. Actually, maybe I will do the close-up right now. I apologize for taking the camera off the tripod. And let me provide a little more light as well so you can see the Arduino. You should be able to see that red is plugged into 5 volts. Then there's 2 ground pins, a VIN pin that we're not doing. I believe that's the equivalent to volts in if we have something plugged in there. So, and over on this side, you should be able to see, 9, 10, and 11 for green, yellow, red, and then orange into 12. And then you see another yellow in pin 5, digital pin 5. And over on this side, I'll just show you that again. And then here is our breadboard setup for our output with our buzzer over there. Breadboard for the output. And then this is the breadboard setup. Actually, I should probably do it this way. This is the breadboard setup for the input, the button of the input. The blue goes to ground on the Arduino. The yellow goes to digital pin 5 on the Arduino. And the red goes to the 5 volts. Back over here. Okay. Now, one of the reasons I usually had the Arduino plugged in already is so I can upload the code and then just show you. But I'm going to plug it in right now. And okay, now we're back to our code, and I think this is one of the reasons I keep it plugged in, because I have to keep jumping back and forth. If it was already plugged in and I already uploaded the code, I guess I could unplug it afterwards. But okay, so let's upload our code. And remember, our code is cut short now. All that stuff that's grayed out is really, we're not using it. We've got the green LED. We've got the button value. Oh, we need the button. Yeah, we need the button. We've got our pin mode for our green LED. We've got our pin mode for our input. We've got our serial, which we're not going to use, but I'm not going to ram it out anyways. we have so that's our void setup function. We have our void loop function, button value equals digital read button. So we're reading digital pin 5 to see whether it has power or not. If button value equals high, turn the LED on. Else, turn the LED low, or turn the LED off. Okay. Let's compile, see if there's any errors. Now, if I pressed upload, it would compile and it would ship it off to the Arduino. And I'll leave the camera on so that when we do the upload, which I'm going to do right now, you can see all the little communications lights going on. Well, hopefully you can see them. I don't know if you can see them. They're kind of light in the camera. But we got a TX and an RX light going on. And, okay, let's pause this. Hopefully our code is okay. And we're back over here. Okay, now that we want to be able to see our light. So if we've set everything up properly, when I press this button, the green light should come on. Look at that. See that? We press the button and the green light comes on. But that's no good. If we want the green light on, we have to hold down the button. And as soon as we let it go, the green light goes off. So now we want to change our code so that if we press the button, the green light comes on and then stays on, and then we press the button again, the green light goes off. Okay, so let's go back to our code. Now, like I just mentioned, we have to keep the button pressed for us to keep the light on. So what we want to do is we want to be able to we want to be able to just press the button, have the light stay on, and then press the button again and have the light go off. Okay, that's easy enough to do. But we have to change our code a little bit here. So we're keeping this the same. Everything up here is the same. We're not using any extra lights or anything yet. Our button value is okay. But we're going to change our if statement. Actually, we are going to use one more thing. Button state. Okay, so we're introducing another variable, button state. We need to not only read the value and then do something with it, but we need to know what the state of the button is, the last time it was pressed. So we need to keep track of that. So if we want our light on, it'll be our button state will be one value. If we want it to be off, it'll be a different value. And actually it'll be 0 or 1. Okay, so let's change down here and then we'll explain it better. So basically we're going to have another if statement here, and we're going to change this one in a minute too. And actually, let me save this as button sensor 2. Save. Okay, so if button value equals, remember we need two equals. We're testing we're testing one against another, so we're not making it equal to something. We're asking it if it is equal to something. So if it is equal to high, whoops, case sensitive. Curly brace. If it is equal to high, then button state. Button state equals 1 minus button state. Okay, we're going to discuss this code in a second here. I wouldn't normally use this code. I'd use the other code that we're going to discuss shortly in the third step. This is actually how I learned to change the button state, or to keep the button on and off. I actually use something different, and I would just you'll see what I use later on, in the next, not later on, but in the next step. So down here we have if button state now equals 1, then we turn the light on. Else we keep it low. We keep it off. So what are we doing here? Okay, so let's assume that we check we read the digital pin button, which is 5. We read digital pin 5, and it's low. So we started off, remember, our button state right now is 0. So if we read it and it's low, then what's our conditional here? If button value equals high, is this code going to run? No, it's not going to run because it's low. We just said it's low. So this code's not going to run. So remember, our button state now is 0. So if button state equals, I'm just going to say equals once. If button state equals 1, which it doesn't, then run this code, else run this code. So it's going to keep that pin low because it's 0. Okay, so now we run through the loop again, and let's assume that the button has actually been pressed. So now we read that the button has been pressed. So now the button it's high. So the button value is high. I'm sorry. Yes, button value is high. So if button value equals high, button state equals 1 minus button state. Okay, well, button state is 0, right? So 1 minus 0 is equal to 1. So now the button state is 1. So if button state equals 1, digital write, green LED high, else digital write, green LED low. Well, it is equal to 1, so the light's going to come on. Now, let's assume that we run through it again. So now, okay, where were we? I just had the, sorry about that, buzzer rang. Okay, so so our first time through, the button was low, so this didn't run, and it was 0, so it means it kept it low. Second time through, we read it, it was high, so it ran this and changed that button state to 1. Now, if button state equals 1, turn the light on. Else turn the light off. So we turned the light on because the button was now equal to 1. So it was high, button state, which is 0, equals 1 minus 0, which is 1. So the LED comes on. Now, of course, so this runs and then this doesn't run. But now we run through the loop again and it's low. Well, remember, our button state right now is 1. So it's low. So do we run this again? No, we do not run this again. So it keeps going through here and the LED stays on. As long as it's low, the LED stays on. So what happens now? So our button value is 1. So what happens now if we if it's high again? Well, if it's high again, what happens is this runs again. So now our button state is 1. So 1, or button state, equals 1 minus button state, which is 1, which is 0. So now it equals 0. So when we press it again, and it comes through here, now button state is 0, so it's going to shut off the LED. Now, you're going to see what I mean about debouncing in a second. We have to debounce the button. And that's going to be the next thing that we do. And it's still going to be part of this same code. Let me make sure I save that code. Okay, let me make sure this is running. Yeah. So let's upload our code to the Arduino and go over to the camera. Once that's done, now we will... Okay, now we're recording again. We have our code uploaded. So when I press this button once, see the LED came on. So that means our button state is 1. And when I press it again, the LED went off. Now our button state is back to 0. So if I do this a couple of times, I can actually get, see? I can actually get it. So it's like I press it and it goes on. But if I hold down the button a little, it's actually going off. So we have a misbehaving button right now. And what's happening is the button, it's, you know, when you press this button, there's a point in time where it's barely touching. So it's like turning it off and on. And so we need to debounce this particular button, or this particular sensor, or whatever you'd like to call it. See how it stayed on a couple of times? See that? So if I go like this real quick, I can usually get it. But do we really want to do that? See, even fast we missed it there. So what we want to do now is we want to debounce that particular, we want to debounce the button. So what it's doing is it's just barely making a connection, and it's off and on real quick. We're just pressing it once, but we're sensing it so fast that it detects all those minute on-offs that you got from, you know, barely touching it. Okay, now I don't know how well I explained this bouncing thing, but it's just, you know, the contact is iffy, especially over how quickly the Arduino can read this. So what we need to do is we need to slow it down a little. So what we're going to do is we're going to put a delay here. And I recommend anything from, you know, 50 milliseconds is a little large. I'd probably say 20 or 30 milliseconds would do. Let's try 20 milliseconds. So once again, I'm not going to go back into the reference. Feel free to go back to help, reference, remember it's your friend, and look up delay. And there's a whole, you know, it gives you examples and everything else. Basically, this stops your program. Your program is linear. It runs this way and then loops back again and runs this way. So this puts a delay in here of 20 milliseconds. 200 milliseconds would be 200, and 2 seconds would be 2,000. So now we have a 20 millisecond delay. So any of those slight on-off connections, you know, when it's not quite touching, it is and it isn't, it should stop that. It should stop that bouncing. So let's upload our code and go back to the video camera. Okay, we're back, and now we have our new code. And we've got a really bad bounce now. Okay, we need to get rid of the delay. Okay, now to get rid of that bounce, we need to add a couple of things. So let's add another. We'll call it old value. Right now it equals 0. And you gotta give me a minute to think here, because this isn't usually the way I do it. You'll see the way I do it momentarily. So basically, what we want is if button value equals high and remember, this is conditionals. When we look at our help, they're not conditionals. They're Boolean operators. So that means and, that's or, and that's not. Like not equals. You wouldn't use that by itself. You'd use like equal, an equal sign, or greater than, or not greater than, or not less than. So we're using and, which if you remember from previous tutorials, both conditions have to be met. So and old value equals low. So our button value has to equal high, and our old value has to equal low. We also need to put a delay in here. And what the delay does is the delay helps stop the program for a second, because it runs so quickly. And anywhere from, like, say, 20 to 40 milliseconds will work. I'm going to use 20 milliseconds. Should work. Okay, so that stops our program. We have a linear program. It runs in this direction, and then boom, it starts at the top again and runs down again. So we're delaying that 20 milliseconds. So we press that button, it reads high, we've got a delay of 20 milliseconds. So while we're pushing down and we get that bouncing, or we're letting go and we get that bouncing, we don't have, it's not going to flicker for us. And then down here, we want, we don't know what the old value is yet. The old value is actually 0, so the old value is low right now. But what we want to do is take old value and have it equal button value. Now we're outside of the if statement here, and we're outside of this if statement. So this is going to run every single time, because we want to store what that old value is. So if the new value is high and the old value is high, then, oh, sorry, my mic was a little low. So if it was still high, if we were holding down the button, then we wouldn't change our state all the time. So this delay helps with the bounce, and this helps with how long we hold the button down. Otherwise, if we didn't have this one right here, this button would just constantly flicker. As we held down the button, it would constantly flicker, and when we let go, we'd have no idea whether it was going to land on or off. So if you want a button to flicker, if you want the light to flicker, just take that out. So I think this should do it. We have button value, we have old value, we have button state. Let's upload this to the Arduino and test it. And I hope I explained that properly. If not, just post some comments and I'll try to make it clearer. Okay, we're back over to the video camera, and we should have debounced our circuit now. Look at that, nice and clean. Now what happens if I hold down the button? Now, if I didn't put in that old value and then put in that second condition that it had to meet, this would be flickering right now. I'm not going to do it for time purposes, because I actually have another thing that I want to introduce. And I want to introduce to you guys. Okay, so that's our debounced code. So let's save that. That's 2. Save. Now we want to save it as 3. Okay, guys, so now for the, actually that's a little distracting back there, so maybe I'll leave this up. Okay, so we have debounced, which is, it works absolutely fantastic. And we can turn our green button on and off. But let's say now we want to take that button and we want to press it once and have the green light come on. Press it a second time and have the green and yellow light come on. Press it a third time, have the green, yellow, and red light come on. And press it a fourth time and have the green, yellow, red lights come on and the buzzer come on. And then we want to press it again and have them all go off. Now that's impressive. All that with one button. And that's the pièce de résistance. That's what we've been waiting for. No, I'm not French. Okay, so one of the first things we want to do is we're going to be using all this stuff now. So I'm getting rid of the remarks. Actually, the first thing I should do is save as. Before you make any changes, you should save it as what you want it to be so you don't accidentally save it over your older code. And I'm going to publish all three of these codes. It should be, hopefully, it should be up on the website by the time I publish this. So if you're watching this now, look down in the comments and you should be able to get the code. Okay, so these are supposed to be remarks, but here we have, we're going to be using all these pins, so we want to enable all this. We're going to get rid of this, but not yet, because I'm going to use it to remind me how to program this down here. Okay, this is the closing bracket for the void loop function. Well, we want to get rid of that, and we want to put that down here again. Now, we also want to get rid of these. We don't want these to be comments anymore. So we need to get rid of that. Okay, so basically what I want to do is I want to grab this. And I'm copying that. And the rest of this is garbage. We don't need it. Bye-bye. So I'm putting these into here, and I'm not explaining it. I probably should have did the other thing first, but it doesn't matter. We'll make these changes momentarily. Okay, so this should start off with 0, 1, 2, 3, and 4. Now, that was just a lot of work there, so I am probably going to save this. File, save. Okay, now we have our button state, and we have our delay, and we have our old value, but we're going to get rid of this. Like I said before, I usually don't use this line of code. It's how I learned, but I actually think there's a better way to do this. And there's always a million ways to do things, and I'm sure after I show you this, I'm sure somebody's going to come up with a different way to do to accomplish the same thing. And if you do, post it in the comments. I mean, I think it would be great. Now, I could never pronounce this. I think it's Modulo. Modulo. I've heard it as Modulus. I know there's no S in here, but I've heard it from other places that way. But Modulo. What it is it's the percent sign. So basically the syntax for this is results, whatever we want, to equal. Remember, whatever's going to go on here, we're going to put into here. So we have dividend, divisor, and what it does is it gives us the remainder. This gives us the remainder of a division problem. So we could do, the result, or this variable equals, 5 divided by. Forget modulo. We'll just do divided by, 6. And that would give us, or actually 10 divided by 5 would give us 2. So the result of 2 would go in there. But this actually gives us the remainder. So if we did 8 divided by 5, well, it goes into it once, but it has a remainder of 3. So the 3 would go in there. And as you can see right here, x equals 7. I can't pronounce that. Modulo. I don't know. If somebody knows how to pronounce it, let me know. X equals 7 modulo 5. The remainder is 2. In this case, the remainder is 4. In this case, the remainder is 0. 5 divided by 5, or 5 modulo 5, the remainder is 0. So x would equal 0. Here, there's a remainder of 4, and x would equal 4. So, but how is this code really used? What I use this code for is to keep a variable within a certain range, and it repeats it. So actually the best way to show this is just to type it out so you can see it. So we're going to get rid of this. So button state equals I don't know what that music is, but that was horrible. Okay, so button state equals, and if you notice I have a parenthesis here. And the reason why I have that is and then we'll do we're going to start actually I think we should just do all of them. Percent sign, which is modulo, whatever it is, let me see if I can get that pronunciation. Modulo, see, I want to say modulo. Modulo, and then we're going to use 5. And we're actually have 5 states. 0 counts, so 0, 1, 2, 3, 4. So we use 5 because 0 counts as a state. So we want 5 states. So what happens is the reason why I have parentheses here is because division, if we go back to some of the basic math and how algebra works, division is actually done before addition. So what this makes sure that this addition is done before it does any of the division. So you need to enclose this in parentheses. And so what happens is, now if I turn this into 4, every time I hit the button it's going to add 1. And we're not actually going to do the math for this. But basically what it's going to do is it's going to add 1 until it reaches 4, and then it's going to go back to 0. If we change this to 4, it would add 1 until it equals 3, and then it will go back to 0. I think the best way is just to show this. Hopefully I get all this code right. Like I said, we're flying by the seat of my pants. Let me save this. Let me upload it to the Arduino. And we'll actually use the serial monitor now. And so we're looking at the button value on the serial monitor. And before we actually look at what we're doing, we're going to open the serial monitor. And we see that 0. Now I'm going to press the button once. And okay, that's actually working. But let me once again, we're showing the button value. It shouldn't be working. Button value is 0, right? If I go like this. button value is 1, like this. Button value is 1. Button value is 1. Why the hell is that working? Okay, you know what? I'm going to leave in all my crazy talk. Because, you know, seeing the issues we run into is, okay, when I was showing you this and pressing the button, you would see 1 and then 0, because we were doing button value, which is up here. We actually want this to be button state. So, these are the things you run into when you're debugging your code and getting it to run. So let's upload this again. And so usually when you watch these tutorials, these people have all this code pre-typed out, or they have it scripted out, and they write it out, and they never run into a problem. And I prefer the real world. Okay, so that's uploaded. Now let's look at our serial monitor again. Now I press the button once. We have 1. We have 2. We have 3. And then we have the buzzer. So it was actually working. And once again, as in one of the previous tutorials, that's how I knew something was wrong with this statement. Because, you know, physically I'm watching it and each light is lighting up when it really shouldn't. And so I had to figure out there was something wrong with this. And it wasn't, this time it wasn't the placement of this statement. And serial, I can't tell you, serial communications is so great for debugging your code. It wasn't actually the position. Last time it was the position where we had this in our code. This time it's what we were looking at. Because I think originally I was going to have you, when we were doing the earlier, just the button come on, I was going to have you look at the button value, and I think that's why I typed that in there. But I decided against that later on. So this actually works. This is our code. Let me save it. We'll get a little bit more into the math later on. Maybe I'll do a lecture on this when my head is clearer. I've had a long day at work, but basically the modulus works. It's basically this, the result of this this divided by this, whatever that result is. So what happens is it circulates through these, and if I had another one. If I added 6, it would go up to 5. Remember, because it counts 0. 1, 2, 3, 4, 5. So that's why we're using a 5. So this is a handy command. So if I was just using on and off, I would just make this 2. And I'd have on and off. So I don't use that other command that I was showing you before. But that could come in handy too. So I showed that code because that's how I learned it initially. So one more time, save. Now let's go look at it. Okay guys, we've uploaded our code. And I'm going to plug in the 9-volt battery here again. And actually, I'm even going to disconnect it from the USB right now. So we've uploaded our code. So, you know, our code is on our brain here. And our little microcontroller brain, our little miniature computer. And I press once, and the green comes on. Remember, we need that debounce. If you may want to adjust that value, that delay value. I use 20 milliseconds. You may want to bump it up if you run into any problems with this code. We press it again, the yellow light comes on. We press it again, the red light comes on. We press it again, and the buzzer comes on. Now, you need to remember, this is not a project. We are not doing a project. What we're doing is we're learning about the input of our different sensors. And this is our button sensor. And this output is coming in handy, apparently, for all these sensors. So what we're doing is we're learning about all these sensors and how they work. Then we're going to learn about all the outputs and how they work. And then we're going to build projects based on that. You know, so basically in engineering, you need to understand the materials that you're using before you can build something. So that's why I'm teaching it in this fashion. But anyways, once again, So now if I hold this button down, see? See, I can hold the button down because we debounced. And, you know, we could do 100 different things if we wanted. And with that one modulus code, and I can do it very fast too. So we can have one button do a whole lot of stuff. And we can actually write code, and I'm not going to do it. I want to get this tutorial up. We can actually write code to, you know, based on certain taps. If we have 2 quick taps do something, and then one other tap brings it out. So we could actually have our own little code here, and with one button, and do, you know, 3 quick taps do this, 2 quick taps do that, and I'm not going to get into that code now, but you can do many things with a single button. Once we get into the output and we start doing an LCD, maybe we'll come back to the button and we'll output every time we have a counter. Every time we press that button, it counts. And as you can see, it's more than just digital read, whether it's high or low, and do something. You can get very creative with your programming with just a single button. Okay, we'll go back over to the and show you what you would do to change your code so that, you know, green and then yellow with the green off, and then red with these 2 guys off, and same thing with the buzzer. Okay, we're back. I think we're back. Yep, we're back. And basically, see these if statements here? We have digital write. We have so the initial state, everything's off. And state 1, we have the green LED on. And the rest are off. So they're all low. Digital pin out. I've explained this in some of the other tutorials, so I haven't gone over the digital write, how we're turning on. These are output pins. Remember, we made them output, and our button is an input. So these guys are outputting 5 volts if we have them high, and they're actually a ground if we have them low, so there's no voltage going out. So as I was just saying on the thing, so what we could do here is, if I took this and I put this low, actually I guess I could show you, this is quick, and so now the yellow is on, but everything else is off. Now down here I could go low, low, and actually I'll save this as 4, and I'll post all this code. So low, low, and then just the red light is on, and how low can you go? How low can you go? And let's save. So now it'll cycle through each one. Instead of green on, and then green and yellow on, and then green, yellow, red on, and then, you know, all off. And then it'll cycle through. So all off, green on, everything else off, yellow on. So it'll cycle through. There's so many things we could do with the button, like I said. And I can have time delay, so I can press the button a couple of times and, you know, increment this, and based on that number, I could have it do, you know, lots of things. If you guys want more tutorials on a single button, I could do that as well. So I already saved it. I'll save it again. We'll upload the code, and we'll look at this one more time. So now we'll look at the code like this, and then we will, oh, we have an error. Okay, I unplugged the Arduino from the computer, if you remember. So now let's upload the board again. Upload to the board again. And now I see the little lights are flashing. My transmit and receive. And that's done. Okay guys, now I just changed the code again, and now we're going to cycle through these things instead of having one on at a time. So keep my fingers crossed, and green, yellow, red, buzzer, green, and all off. Sorry, all off. Green, yellow, red, buzzer, all off from a single button. And like I mentioned before, I could use delay statements so that I could have multiple button pushes. Well, I don't know if actually delay statements would work. But anyways, I've done programming before where I've had multiple quick button presses, and it's done one thing instead of just cycling through stuff. So you can decide which one you want to do. If you want the yellow light on, 2 quick presses gets it. If you want the green light on, 1 quick press, and it would go to the green. So there's many things. You can have all kinds of controls with a single button. And I think we've had enough of buttons today. Like I mentioned earlier, my next tutorial is probably going to be an electronics one. See you soon.